Hey guys, how are you doing? I hope you are doing fine. Let's see another new question. This is also a famous question. I've seen this uh, some number of places, so I guess it is a famous question. We have 2018 pieces of wire. I guess this question was made in 2018 or was posted in 2018. I don't know why 2018 is exactly written, but yeah. Anyways, 2018 pieces of wire. Next, attach end to end of a wire to another end, choosing randomly. So all the pairings are equally likely. When the process is completed, there will be loops. No wire ends unattached. Obviously, like this is the condition for uh, uh, like the condition for termination of this, and the number of loops will range from 1 to 2018. Obviously, 1 to 2018. Yeah, right. It is because let's say there are 2018 wires. We join this to this, we join this to this to this, and this to this. So how many loops are there? 4, right? Let's say we join this to this and this to this. So how many loops are there? 3, right? If we join this with this and this, how many loops we have? 2, right? And because this is one loop and this is one loop, so there are total 2 loops. So basically we can form, and finally if we join all of them linearly and the last ends together, then it will form a single loop. Anyways, so you have got how all types of loops can be made, right? So we have to find out the average of the expected number of loops which will be made, right? So first of all we need to find out the number of operations which will be there. So I'll like to generalize this question and not write 2018. I'll write n pieces of wire. Okay, n pieces of wire. How many free ends does a n pieces of wire have? There are 2n free ends. That's clear, right? How there are 2n free ends? Because each wire has 2 free ends, so 2 into n, right? Free ends. Now at each operation what happens is, if you see, the number of free ends decreases by 2. Either you connect this with this, or either you connect this with itself, or either you connect this with this. So number of free ends getting decreased by 2 in each case, right? So if you formulate like and how much it decreases by, it gets decreased by 2. So if you formulate that in ith operation, a number of free ends will be equal to 2n minus 2i plus 2. Why? Because when we will be doing the first operation, there will be 2n free ends. For I equal to 2, there will be 2n minus 2 free ends. If there are 2n minus 2i plus 2 free ends, how many non-loop wires are present? How many non-loop wires are present? N minus I plus 1. This is pretty much clear, right? Let's say after the first operation, how many non-loop, if we loop this to this, how many non-loop wires are present? 3. If we join this to this, how many non-loop wires are present? 1, 2, 3, isn't it? If we join this to this, how many non-loop wires? 1, this is 2, this is 3. So basically it also decreases linearly with 1. Okay, so now what is the probability? Okay, leave the probability. Now we have to find the average number of loops, right? Average number of loops. So whenever I have said average number of loops, I have always said either think of indicator random variable or the actual formula. Actual formula would have been useful over here if we knew how many exactly loops at each stage we can create, and how many loops and it's pretty difficult to understand how many loops we will be creating in the process. Reason being that we are joining 2 ends, we don't know exactly which end we are joining and how we are joining, and that, so it's pretty unclear in that context, right? So indicator random variable is a good option over here, also because indicator random variable can solve problems which has number of something, because we can calculate it using sum of some indicator random variables, right? It also asks for. So let's define our indicator random variable I of I is equal to 1 if I of I is 1, that is the indicator random variable, is 1 if loop is formed in ith operation, 0 if not. Okay, this is fine. So what is the number of loops? Number of loops is I1 plus I2, that if it is created in the first operation, then it will give 1 or else it will give 0. So I of n, completely fine, we are completely sure of what happens, right? Now what will be E of n? E of n will be summation of E of I. I've discussed this a lot of times, because E of n will be E of I1 plus I2 plus I3, and which we can write as E of I1 plus E of I2 plus E of I3, right? I have discussed this a lot of times. I will be 1 to n because there will be at max n operations. After n operations there will be no more operations, right? After, because there are 2n free ends and every time it decreases by 2, so n operations in the max which we can go. Actually n minus, we should write n minus 1 over here, I feel, because at the first operation no, it's fine, we should write n, there should be n operations, my bad. I was just thinking something else. Anyways, now we have to find out what is E of I for a certain I, right? Let's see what it is. It is basically something like, we have to find out the probability 1 into probability of forming loop at ith operation plus 0 into not forming, p of probability of not forming. So this is anyway 0, we don't care about this. We care about the probability of forming a loop at the ith operation, right? So let's find out forming loop at ith operation. What is the probability of forming loop? What is the probability to join any two free ends? What is the total number of ways to join any two free ends? To join, you have to find out this, any two free ends, it is actually the number of free ends we have, C2, let's select any two of them, right? And total number of ways we can form a loop is basically, we select a wire, we already discussed that the number of straight wires will be n minus I plus 1. We select a wire and it's done. When we select a wire, either sides of that wire, we don't care about which side, the other side will be our, because we have to form a loop, the other side will be our next choice. Obviously we select the upper part, we have to select the lower part for the next case, or if we select the lower part, we have to select the upper part for the next case, right? So this is it. So what is the probability? Let's say I denote this by p, because I don't want to write it so many times. N minus I plus 1 by 2n minus 2i plus 2, I am writing 2n C2 by 2. So this get cancelled, right? So basically our p turns out to be, p of I basically for the ith operation turns out to be 2n minus 2i plus 1, isn't it? So the summation of that, which is equal to E of II, so summation of E of II from I equal to 1 to n is what exactly? Can you tell me? Sorry for the disruption. I got a message which was, I guess, important. Anyways, I'll check onto it later. 2n minus 2i plus 1. So you can write this sum as 2n plus 2n minus 1 plus 2n minus 3 plus dot 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 1 by 1, right? So basically it's the sum of all the odd numbers from 2n to 1 in harmonic form, 1 by 2n minus 1 plus 1 by 2. So that is it, right? So this is it. I hope you like the video. If you liked it, please subscribe and share it with your friends. Okay then, bye.